Hello! Welcome to the Spring Semester Final Review, Part 2. Part 2 begins with Unit 7, Polynomials. And in polynomials, we were able to look at the graph of a polynomial and determine some of its key features. So the first one here is the degree. Starting with the degree, when we determine the degree, we count the curves and we add 1. So here we have a curve here and a curve here. So 1, 2 plus 1, our degree is 3. Another way to do this that we did not talk about, that might be easier for some of you, is to count the direction. And what I mean by that is starting on the left-hand side, we're going to count the directions that the graph goes. So this graph goes down, then it goes up, then it goes down. So that's down, up, down, 1, 2, 3. And so our degree is 3. So we can do this by counting the curves and adding 1, or by counting the direction, starting at the left. All right. Next, what is the end behavior? End behavior is talking about the ends of the polynomial. What are the hands doing? If this was a hand, what is that hand doing? This one's facing up, and this hand is facing down. Okay, let's take a look at that. So all we need to do for end behavior is read this and determine what direction the graph is going when this is happening over here. So right here we have x approaches negative infinity. So where is negative infinity on the x-axis? Negatives go to the left. So as x approaches negative infinity, what is our graph doing? Our graph is going up, up towards positive infinity. And that's it. A lot easier than it seems. All right, let's look at the next one. As x approaches positive infinity, what is our graph doing? Well, the x-axis goes positive to the right. So as x is approaching the higher numbers, where is our graph going? Our graph is going down towards negative infinity. And the last one here is to label the x and y intercepts. X-intercepts are where the graph crosses the x-axis, and y-intercepts are where the graph crosses the y-axis. So here we have a y-intercept at 0, 90, and we have two x-intercepts, one at negative 3, 0, and one at 5, 0. All right, moving on, long division. So we learned how to divide polynomials using two ways, long division and synthetic division. So let's do a quick refresher of long division. Here it says we're going to take this polynomial and divide this other polynomial. So we need to set up a nice little box here. And on the outside, we're going to put what we're dividing by, x plus 2. And what we divided from goes on the inside. Okay, so we're going to take this first number on the inside and the first term on the outside, and that's what's being divided. So here we have x cubed divided by x. That leaves us with x squared. Notice how I'm placing that x squared above the other x squared. Okay, now we're going to take, okay, so we follow this acronym called DMSB, Daddy, Mommy, Sister, Brother. This is divide, multiply, subtract, and bring down. So first we divided. We said x cubed divided by x, we're left with x squared. Now we are going to multiply. So we're going to take this term and multiply here and here. So let's multiply it first by x squared. X times x squared. So x squared times x is x cubed. And x squared times 2 is 2x squared. Now, because our next step is to subtract, we're going to make them negative, and we're going to subtract from the numbers above. So now we have x cubed minus x cubed. Those cancel out. 2x squared minus x squared. Those also cancel out. So we're left with 0. Our next step is to bring down the next term, and we will go right back into dividing again. 4x divided by x. That's going to leave us with 4. But that number doesn't have an x, so we're just going to put it right here. Just 4. Now, in order to multiply back, we're going to say 4 times x and 4 times 2 for 4x and 8. Let's go ahead and bring down that next term. This problem is a little different because usually you will end with a number here and it continues nicely, but in this case, those first two terms cancel out. So that's why we have to bring down twice in one turn. This one's kind of confusing. Don't overthink it. It's not that serious. Okay, so we need to change signs because we are subtracting. 4x minus 4x cancels, and 2 minus 8 is negative 6. So it says find the remainder. Our remainder here is negative 6. If we wanted to say our answer or the quotient, we have x squared plus 4 minus 6 over x plus 2. This would be our final answer. All right, last one, another long division here. So we're going to take the polynomial, place it on the inside, and the one that we're dividing by goes on the outside. So again, we're following DMSB, daddy, mommy, sister, brother, which means divide, multiply, subtract, and bring down. So starting with the first term, this one divided by this one. 2x squared divided by 2x, all we're left with is a single x. Then we can go into multiplying. X times 2x and x times 3. X times 2x is 2x squared, and x times 3 is 3x. Now it's time to subtract, so we need to change the signs. Boom, and subtract. 2x squared minus 2x squared cancels, and negative 17 and negative 3 is negative 20x. We're done subtracting. Now we're going to bring down that last term. Now, going back to dividing once again. 20x, negative 20x divided by 2x. Well, 20 divided by 2 is negative, so negative 10. And then we can go back into multiplying. Negative 10 times 2x and negative 10 times 3. Negative 10 times 2x is negative 20x, and negative 10 times 3 is negative 30. Now we need to subtract or change signs. And we have negative 20 plus 20, and negative 38 plus 30 leaves us with a remainder of negative 8. If we wanted to write our answer, we would say the answer is up here, x minus 10, and then plus or minus the remainder divided by whatever we were dividing. All right. Now, if you're worried about this, there is division of polynomials on the review, or sorry, on the test, but it is a multiple choice test. So do you have to use long division? No, you don't. You can use synthetic division if you're more comfortable with that. So let's go ahead and move into the synthetic division. All right, here it says use synthetic division to find the remainder. So when we set up synthetic division, we set up this big L, and across the top of the L here, still on the inside, we write our exponents. I see that our highest x is x cubed, so that's going to go first, x cubed, and then we just go down. X cubed all the way to a constant. That's what our pound sign represents, a constant. What are we dividing by? What we're dividing by goes on the outside, but we can't put plus 3. We have to put the answer when we set that factor equal to 0. We find that x is negative 3, so that negative 3 is what goes on the outside. Now below all these x's at the top, we're going to put the coefficients. So we have 2, 3, negative 4, and 8. All right, so how do we get started? We bring down, use different color, bring down the 2 below, and we multiply. 2 times negative 3. That's a negative 6. Now we add or subtract 3 minus 6. That leaves us with negative 3. Next, negative 3 times negative 3 is positive 9. Now to combine negative 4 plus 9, we get 5. And we multiply again. 5 times negative 3 is negative 15. Now to combine 8 minus 15, we are left with 7, negative 7. All right, now it's time to write our answer. The last number you get here is going to be your remainder, and these other numbers are the coefficients of our answer. Now we started with our highest degree of x cubed, so our answer has to be 1 degree less. So this 2 is going to be x squared, this 3 is going to be x, 5 is the constant, and the remainder is 7. So writing my answer out nice and pretty. There we go. And our remainder is always divisible or set to be divided by the divisor that we started with, because this part, this remainder, could not be perfectly divided by the divisor. So it just sits there above the divisor in a fraction. All right, next one, let's go ahead and set up our big L. Across the top, let's start with our coefficients, or sorry, not coefficients, the degrees, the exponents. Our highest degree is 4. We just set it up going down. Okay, now we can go ahead and write the coefficients below. We had a coefficient of 2, 2, negative 12, 1, and 6. Here we have x plus 3, so we're going to say x plus 3 equals 0. Solve for x. So what we're dividing by is negative 3. Now let's start solving. We're going to bring down the 2 below, and we multiply. 2 times negative 3 is negative 6. Then we combine. 2 minus 6 is negative 4. Now we have negative 4 times negative 3. That's negative 12. Negative 12 and negative 12 is negative 24. Oh wait, I messed up. Okay, negative and a negative is a positive 12. Now, negative 12 and positive 12 is 0. We go back into multiplying. 0 times 3 is 0. We combine again. 1 plus 0 is 1. Then we multiply. 1 times negative 3 is negative 3. And last we combine. 6 minus 3 is 3. Just like we said in the last video, our final number is the remainder, and these other numbers are going to start off 1 degree less than what we started with. So we started with x to the 4th, so our answer is going to start with x cubed, and then it just goes down one by one. So writing our answer nice and pretty, we have 2x cubed minus 4x squared. We don't need to write the 0. Plus 1. Our 3 is positive, so we're going to say plus 3 over what we were dividing by. All right, solving exponential equations. When we solve exponential equations, the bases need to match. If the bases don't match, we cannot set the exponents equal to each other. Here, our base is 3, our other base is 3. Because they match, we can go ahead and set our exponents equal to each other and solve. So I'm going to subtract the x to the other side and subtract the 1 to the other side. Divide by 4, giving us this x equals negative 1/2. All right, next one. Next one here we have 4 to the x plus 1 minus 6 equals 10. So here we don't have two exponents and two bases. So let's start by adding the 6 to the other side. And although we don't have two exponents, all whole numbers have an exponent of 1. And we can definitely rewrite 16 to be 4. What exponent does 4 need to be 16? It needs a 2. So we can rewrite this right side. Instead of 16, we can say 4 squared. And now our bases match and can cancel out, setting our exponents equal to each other. We solve for x. All right, next page. Miss Serio bought a new Prius. The equation which describes the value of her car as a function of time and years is this equation. What is the value of her car after 3 years? 3 years. Okay. Well, that little x as the exponent, that represents time. So in order to solve this problem, we're just going to plug in the time, t, for x. So plugging that in, our equation is going to look like this. Now to solve this, all we need to do is type that in the calculator. Okay. The equation we're plugging in, 23,000 times 0.91 to the 3. 23,000 parentheses 0.91 to the 3. We get 17,332 and 13 cents. So this is how much her car will be worth in 3 years. All right. Now, is her car value growing or is it decaying? Let's talk about that for a second. When we use an exponential growth or decay function, the b value represents our rate and when our rate is greater than 1, this is growth. But when our rate is less than 1, this is decay. Moving on to the next section, graphs and key features of exponential and logs and transformations. So use the following equation for the questions in this section. What is the domain for this equation above? So here they are giving us an equation and asking for the domain. So how can we do this? We can do this two ways. The first way is the easiest way would be to just put it in Desmos and look at the graph. So here's our equation. So we're going to say 2 times 2 to the x plus 1. X, oh, that's multiplication. Okay, x plus 1. Oops. There you go. Here's our graph. And the domain, when we talk about domain, we're talking about the x values. We're looking at the x-axis from left to right. So from the left here, as the x values increase, where is our graph going? Our graph is going up. Where does our graph begin on the left? Well, it has a line coming from the left, so our domain is negative infinity to positive infinity. And this is the domain for all exponential functions. What is the equation of the asymptote? All right, we have an asymptote. We have a horizontal asymptote right here going through -6 through the y-axis at -6. And true or false, the graph of the above represents an exponential decay. Well, this graph is going up, so this is going to be growth, so this is false. So when the graph goes like this, it's growth. And when the graph goes like this is decay. Last, list the transformations to the parent function. Now, we don't need the graphing to do this. All we need is to look at our equation. So, exponential equation transformations, we have a times the base to the x minus h plus k. So the transformations we have here are a, h, and k. A, just like we saw in yesterday's video, either represents a vertical stretch or a vertical compression. If A is less than 1, it's a compression. If A is greater than 1, it's a stretch. And H moves left or right. Left if it's showing plus, and right if it's showing minus. And then K goes up and down. So here, looking at our equation, we have 2 for A, which means it is a vertical stretch. Next, we have plus 1 as our H value. So we know H is moving left 1. Lastly, we have K, which is -6, so we're going down 6. Lastly, we just have a few problems left. So right here, operations of logs. Expand the following logarithmic expression. So this is the inside of our log, and what's happening is we're saying b times a times e. So how do we expand addition? Addition becomes multiplication when we expand. So starting with this one, we're going to separate all three items that are being multiplied by showing addition and making them all their own log. All right, over here, we need to expand again. We have some multiplication. We have 2 times x cubed, and then we have some division. So again, multiplication can be expanded to addition. Did I just say that? I wrote this backwards. Multiplication expands to addition. Multiplication expands to addition, yes. And division expands to subtraction. So here we have 2 times x cubed. So first off, we're going to start with log 4 of 2 plus log 4 of x cubed. And then the division means subtraction, so we're going to have log 4 of 5. Now, one more thing we need to do here is this exponent of 3. Exponents can be rewritten as coefficients when we expand. So our final answer here is log 4 of 2 plus 3 times log 4 of x minus log 4 of 5. All right, now we need to rewrite these from log to exponential. So here we use the base and switch. And base and switch says we identify the base. So the base is going to become the base. So we can start with the base on the log, and that base becomes the base of the exponent. Or backwards here, we have the base of the exponent becomes the base of the log. So let me just start over again. All right, so we need to identify the base, and the other two switch places. One goes in and one goes out. So here our base is x. You can see it nicely. Here's our base, write it big. The other two numbers, switch places. The 6 comes inside to become our exponent, and the b goes outside to become our answer. And that's it. Let's take a look at the next one. What's our base here? Our base is q, so we write the base of the log to be q, and the other two numbers switch places. This one goes inside or outside, and this one in. That's it. That's all we need to do. On this last one here, 2 more problems. Here we have solve the following logarithmic expression for x. Okay, so when we are solving, we want the log of something, the log of something equal to the log of something else. And then we cancel those logs, and those insides can be equal to each other. So taking that, this rule is called 1 to 1. We need 1 log on the left and 1 log on the right. So in this case, we do need to condense the right side because on the left we have 1 log, so that's good. But on the right we have 2. We can't have 1 to 2. We have to have 1 to 1. So this right side, how can we condense these 2 logs into 1? Well, we have subtraction here. And what we did on the last page was we said division can expand to subtraction. But same thing, the reciprocal of that is that subtraction can expand to division. Or condense, condense to division. So instead of saying 15 minus 5, we're going to say 15 divided by 5. Now 15 divided by 5 is just 3, so we can go ahead and put the 3 here. And now we can set the logs, we can cancel the logs and set the insides equal to each other. And solve. Subtract the 2, and we divide by 3. Okay, last problem. Solve the following log expression for x. Okay, same thing here. We have 2 logs on the left and 1 log on the right. How can we condense the left side to be one single log so that they can cancel out and we can solve? Well, in between we have addition. And on the last page we said addition expands to multiplication. Or sorry, I think we said that backwards. We said multiplication expands to addition, but here we need to condense. So we're going to take addition and it's going to condense to multiplication. So what we need to do here is rewrite the 2 plus x as 1 log, but on the inside we have 2 times x. Now that we have 1 log on the left and 1 log on the right, they can cancel, and we set the insides equal to each other and solve for x by dividing by 2. And that's it. All right. Make sure you're completing your review. There will be 5 extra credit points on the test, and your cheat sheet is also going to be 5 extra credit points on the test as well.